Okay, GoA 1. So there's no automation, train operation. So GoA 1, this will be considered like your conventionally signal system, and that's the majority of the systems around the world. That's how I interpreted GoA 1. Reading that standard based on what I could understand from it. The driver is in control of the train, which includes propulsion, braking, and door control. So the driver is braking, the driver is accelerating, the driver decides when to open doors and when to close the doors. The driver is using wayside signals or cap signal to determine if it's permitted to move forward or not. So if the signal is permissive, it moves. If the signal is restricted, the driver is responsible for stopping the train. The system may perform continuous or semi-continuous supervision of the driver. So it may be that the system is continuously monitoring the train's speed to make sure that it does not exceed the speed limit for that section of track. It could be a maximum speed for that entire system, or it could actually monitor the speed at 60 kilometers for one section. Maybe when it's going around a curve, it's permitted to do only 40, so it may monitor that. So it may have a continuous monitoring as well. In other systems, it may be that speed is monitored only in certain locations. This can be when the train is approaching a signal. In Europe, they have these induzi systems where when the train gets to a certain distance before the signal, the onboard system will detect it and determine, in order to stop at the signal in front, the train has to be moving at a certain speed and slowly decrease the speed as it gets to the station. And if it does not, emergency brake the train. These sort of systems would be considered part of GoA 1, although they're not necessary. Basically, the point of GoA 1 is that the driver's in control, the driver's looking at the signals, the driver's accelerating, decelerating, deciding on the speed required for that train to be on that certain piece of track. Once the train is in the station, it is again the driver's responsibility that it's safe to A, open doors, close doors, and then to decide when to depart the station. So basically, GoA 1, the driver and operation staff are in complete control of the system, and they are responsible for the safety of that system. So in a GoA 1 system, the items that I've highlighted in orange are the functions that are required for GoA 1. Ensure safe route, ensure safe separation of trains, and safe speed. In this case, they say partly by system, and I'll go into that in a second. So the first function they talk about is ensure safe route. So again, this is conventional signaling. I'm sure many of you are aware of it. It's when a signal is called or a route is selected by the operator, the relay logic or the Boolean equation, if it's a microprocessor-based system, it will determine if it's safe for that train to move or for that route to be set. It'll ensure that there's no other train in the requested path, ensure that all the switches and points are locked in the correct position. Any other conditions included in the logic, such as maybe platform doors are connected to the logic, station emergency stop button may be incorporated into the logic. Whatever other functions may be incorporated into the logic, the relay or the Boolean logic will determine if it's safe to set the route beyond a certain signal. And that's safe route for a GoA 1 system. Once the train passes the signal, the route under the train can't be canceled. These are the basic interlocking or routing capabilities that a conventional system has. There may be others, but the point is, it's your conventional system fixed block approach that's used around the world. It's very common. Second is ensure safe separation of trains. So in a GoA 1 system, again, conventional signaling, usually it's a minimum 1 block or two signal separation that is maintained between trains. When a signal is called, the logic will only set the signal to a permissive aspect if the control line in front of the train it's clear. And under worst case failure, if a train violates the signal, the train will emergency brake to a stop without colliding with the train in front. So 1 block separation is what's considered safe train separation in a GoA 1 type of a system. And again, that is your standard conventional fixed block signaling that's used there. Ensure safe speed. Now, they're saying that it's partly by the system, so it's not a full monitoring of speed. So the onboard system is installed to monitor train speed. If the train speed exceeds a certain permitted speed limit for that section of track, the onboard system will apply either the EBs or service brake the train. Partly can mean that it's only applied on certain parts of the track, such as when approaching a signal that I mentioned earlier. Monitor and ensure the maximum speed is not. So it partly can mean that it may be a simple system where it's only monitoring the maximum speed for the entire line, such as 80 kilometers an hour for the entire track. Or it may be that it's only certain parts of the track, such as when you're approaching a signal, you want to make sure that the train is properly reducing its speed as it approaches the signal. So that could be a partly approach. Sorry, that's what it's meant by the system is partly monitoring the train speed in the system. So these are your three functions: ensure safe route, ensure safe separation, ensure safe speed. And again, as I mentioned, that is a conventional system. That's the way most conventional systems operate today. I would consider those to be like a GoA 1 type of system with some automation in terms of speed monitoring. An example of a GoA 1 system would be New York, London Underground, TTC, and other systems around the world. Now, that's my interpretation of GoA when I read that standard. There is no automation. If there is no automation, then you're using relay logic or Boolean logic via a microprocessor, and you're following the conventional rules that have been in place for the last 100 or some 150 years for rail urban transit signaling.